ECDF's chair on energy economics and energy risk management is focused on the management of energy risk and the analysis of electricity markets. A big part of that work is the analysis of renewable energy integration and demand response integration in our systems. Our group is focused on the analysis of the operation of the system and the markets around it. Because of the large-scale integration of renewables and the fluctuations and the uncertainty associated, we need backup reserves that can support and balance the system, since we cannot store energy, and that undermines both economic goals and the environmental goals of renewable integration. What we do is we run detailed economic models of the entire European market with high fidelity of technical and economic information about both the generation side and the demand side, and we analyze how smart grids will look 10, 20 or 30 years down the line given the ambitious renewable integration targets of the European Commission.
The kind of questions we're looking at regarding smart grids, they are to find a regulatory model that would reimburse the operators so that they can get a fair return for the investments they do, and in the same way making all agents working towards a common goal. A smart grid is not only a technological innovation, but it's also a way to introduce the grid users to become micro producers and to become more active in demand-side management. All of this forces the operators to send signals to them, information, and to get information back in order to optimize their own grids. This is valid not only when they operate the grids, but also when they make investments in infrastructure, in grid equipment, in metering devices, and in devices that they use to integrate back with market operators.
Another area of activity is the active control of the transmission network. So how can control systems actively manage the network through various technologies like flexible AC transmission systems, HVDC, phase shifters. Our methodology relies on large-scale parallel computing. One of the advantages that we bring in is the ability to simulate large-scale systems with thousands or millions of decision variables involved, which is pertinent throughout the whole chain of the electricity markets. And for that purpose, we're accessing one of the largest supercomputers in the world, hosted in the Lawrence Livermore National Laboratory in the United States.